Today we will be discussing about the second part of error analysis, and in this video we will discuss that how error affects the four operations in mathematics, that is addition, subtraction, multiplication and division. So we will discuss it one by one. So let's start with the first two operations, that is sum or difference, that is addition or subtraction. So we will see that how errors affect addition or subtraction of two quantities. So to start with, let us assume that x is a quantity which is equal to a plus minus b, and delta a is the absolute error in the measurement of a, and delta b is the absolute error in the measurement of b, and delta x is the absolute error in the measurement of x. Then x plus delta x is equal to a plus minus delta a plus minus b plus minus delta b. It can be written as a plus minus b plus minus delta a plus minus delta b. But we have taken x as a plus minus b, so we can substitute a plus minus b as x. So by cancelling x from both sides, we can get delta x is equal to plus minus delta a plus minus delta b. So delta x is equal to plus minus delta a plus minus delta b. So the four possible values of delta x are delta a minus delta b, delta a plus delta b, minus delta a minus delta b, and minus delta a plus delta b. So we can get these four sets of values for delta x. Now we have to find the maximum possible error in delta x. So among these four possible values of delta x, the maximum errors are delta a plus delta b and minus delta a minus delta b. So these two values can be written in one line as delta x is equal to plus minus delta a plus delta b. So this is what? This is the maximum absolute error in sum and difference of two quantities, that is delta x is equal to plus minus delta a plus minus delta b. So which is equal to sum of the absolute errors, in the individual quantities. So this is our maximum possible error. And for example, we have taken a problem that the length of two bodies are measured to be L1 is equal to 10.2 plus minus 0.02 centimeter. So L1 we have taken as 10.2 plus minus 0.02 centimeter, and L2 is equal to 6.4 plus minus 0.01 centimeter. So the problem here asks to calculate the sum and difference in lengths with error limits. So L1 and L2 are given. So delta L is equal to plus minus delta L1 plus minus delta L2, which is the maximum possible error. So which is the maximum possible error in calculating the value delta L, which is plus minus 0.2 plus minus 0.1 centimeter, which is plus minus 0.03 centimeter. So this is the maximum possible value of delta L. Now L1 plus L2 is equal to 10.2 plus 6.4, which is 16.6 centimeter, and L1 minus L2 is equal to 10.2 minus 6.4, which is 3.8 centimeter. So we get the values of L1 plus L2, L1 minus L2, and also the maximum value of delta L. So our answers are sum of lengths is equal to 16.6, that is this value, plus minus 0.03, that is this value, and the difference of lengths is 3.8, that is this value, plus minus 0.03 centimeter. So in this way we can calculate, or we can include the errors in case of summation and difference, that is addition and subtraction of two quantities. So let us move to the next one, that is errors in product. So here we will see that how errors affect in the case of product of two quantities. So to start with, let us assume that x is a quantity which is the product of other two quantities a and b. So x equal to ab, then x plus minus delta x is equal to a plus minus delta a multiplied by b plus minus delta b. So from the left hand side we take x as common, and we get x multiplied by, within bracket, 1 plus minus delta x by x, and from the right hand side, from this term we take a common, and from this term we take b outside. So the right hand side becomes ab multiplied by 1 plus minus delta a by a multiplied by 1 plus minus delta b by b. Now x is equal to ab, so from this side and this side we can cancel this one and this one. Now we are left with this one, that in the left hand side 1 plus minus delta x by x is equal to, now we have to multiply these two terms. So 1 plus minus delta b by b plus minus delta a by a plus minus delta a by a multiplied by delta b by b. Now these two terms, that is delta a by a and also delta b by b, is very small. These two terms are individually very small, so product of these two terms will be also very small. So we can neglect this term and we can write delta x by x is equal to delta b by b plus minus delta a by a. So here we have neglected this term because this is very small quantity. So the maximum possible value of delta x by x, as we have seen in the previous case, that this is the four possible values. This equation or this expression has four possible values, and among these four possible values we are only interested in the maximum possible value. So the maximum possible value of delta x by x is equal to plus minus delta a by a plus delta b by b. So this is our maximum possible error in case of product of two quantities. So the maximum fractional error in terms of statements, so the maximum fractional error in product of two or more quantities is equal to sum of fractional errors in the individual quantities. So this is our error or maximum error in case of product of two quantities, or we can say that we can extend it for more than two quantities. So now we will move to errors in case of division. So we can take that x is equal to a by b. So here we are taking a quantity x which is a by b. So x plus minus delta x is equal to a plus minus delta a divided by b plus minus delta b. Now as in the previous case we have done, here we also take x outside of the bracket, so we are left with 1 plus minus delta x by x, and in the right hand side, a in the numerator it is a multiplied by 1 plus minus delta a by a, and in the denominator it is b multiplied by 1 plus minus delta b by b. So x is equal to a by b, so we can cancel x and a by b, so we are left with 1 plus minus delta x by x is equal to 1 plus minus delta a by a, and the term in the denominator we can write it as 1 plus minus delta b by b whole to the power minus 1. Now here in the next step, that is from this step to this step, we have taken the binomial expansion, that is 1 plus x whole to the power n can be approximated as 1 plus nx, or if this is plus minus x, then here it will be also plus minus x. So this is up to the first term we can approximate, and we can do this when x is very less than 1. So here we have done it in case of this term. Here this is 1 plus minus delta b by b whole to the power minus 1. This minus 1 is multiplied with this plus minus, and this becomes 1 minus plus delta b by b. And in the next term we have just simply multiplied the terms in the right hand side, and again since this term delta a by a multiplied by delta b by b is negligible, we can neglect it, and we are left with, and also this 1 and 1 cancels out, and we are left with delta plus minus delta x by x is equal to plus minus delta a by a minus plus delta b by b. So again the same case happens here, that the maximum possible value, we are only interested in the maximum value of the error, which is delta x by x is equal to plus minus delta a by a plus delta b by b. So in statement, the maximum value of fractional error in division of two quantities is equal to the sum of fractional errors in the individual quantities. So this is the case of division, and we are dealing with errors in division in this way. Now suppose that we have an expression like x equal to a to the power n divided by b to the power m, that is the terms are raised to some power. So what we will do in that case, while we are given the terms such like this, then we have to take the log base e, that is ln, in both the sides, and we get ln x is equal to n ln a minus m ln b. Since we are using the property of log, just we are using the properties of log, and we are getting this term by taking log to this equation. So differentiating both sides, we get dx by x is equal to n into dA by a minus m dB by b. So in terms of fractional errors, this can be written as delta x plus minus delta x by x is equal to plus minus delta n multiplied by delta a by a minus plus m multiplied with delta b by b. So the maximum value of delta x by x in this case will be delta x by x is equal to plus minus n delta a by a plus m delta b by b. So these values we get from this one, and again this expression has four possible values, and among these four possible values we are only interested in the maximum value. So we are only interested in the maximum error. So in this way we are dealing with the errors in case of a quantity and which is raised to some power, and this expression is very important for solving different kinds of problems in our examination. So we have taken here some examples on the theory which we have learned till now. So the problem says that the mass and density of a solid sphere are measured to be 12.4 plus minus 0.1 kg and 4.6 plus minus 0.2, sorry, this will be yes, and this is right, this is kg and this is density, so this is kg per meter cube. So the problem says that calculate the volume of the sphere with error limits. So here mass is m plus minus delta m, which is 12.4 plus minus 0.1 kg, and density is rho plus minus d rho, which is 4.6 plus minus 0.2 kg per meter cube. So volume is V equal to m by rho, which is 2.7 meter cube, and delta V by V, the maximum possible value of delta V by V is plus minus delta m by m plus delta rho by rho, as we have learned. So delta V is equal to plus minus delta m by m plus delta rho by rho multiplied with V from this term. So by putting all the values we get the value of delta V. So delta V is the maximum error in case of calculating the volume in this example. So V plus minus delta V is nothing but this 2.7 plus minus this delta V, that is 0.14 meter cube. Now we will move to the problem number 2, that is example number 2, which says that a physical quantity is given as x equal to a square b divided by c to the power 1/3 multiplied by root under d is calculated by using measured quantities a, b, c and d. If the errors in the measurements of a, b, c and d are 1%, 2%, 3% and 4% respectively, then find the percentage error in the measurement of x. So we are given this quantity, that is x equal to a square b divided by c to the power 1/3 multiplied by root under d. So delta x by x is equal to 2 delta a by a plus delta b by b plus 1/3 delta c by c plus 1/2 delta d by d. So this is the case of the quantities raised to some power which we have learned in the theory. So by putting the values of all the quantities, that is delta a by a is given as 1%, delta b by b is given as 2%, delta c by c is 3% and delta d by d is 4%. So by putting all the values we get the value of delta x by x as 7%. So this is the percentage error in the measurement of x. In the next video we will take some more examples from different competitive exam to get the feeling of this theory.